Alright, this is going to be a second walkthrough for the Milltronics lathe here. This one's going to be a little more involved. So we've got this part here. See, we're going down to 630. Our material's 340 right, or 750 right now, 3/4. So we're going to be turning the outside. We're going to be doing this undercut here. We're going to relieve this corner. We're going to be doing some threading, and we're going to be doing some boring. So first things first, we're going to turn our outside diameters. This is going to be a new program. So we're going to go program, conversational, new. We're going to stick with that 498. Like I said, the new thing between 498 and 507. You can use, I'm actually going to rename this one later and end up saving this program. I just keep the part numbers and stuff out of my demonstration here. So it's going to ask us if we want to replace the program. Yes. Okay. I'll wait till later to name it. Material length, again, this is just for our graphing purposes. So even though our real part is almost 8 inches long, I'm just going to put in 1 inch length because that's about all we'll be working with. Our diameter on our material right now is 3/4. We're going to store that. We're going to call up our tool. And again, tool 6 is our most commonly used tool for the facing and the turning. We're going to stick with that one. 10 thou per revolution. Max out our RPMs at 1250. Surface speed. I'm going to keep this a little bit slower just because we've already got this section here turned back to a relatively small diameter, so just to keep some of the pressure off of it. Spindle on clockwise, coolant on. We're going to store that, and we're going to be turning and roughing. So we're going to, this is asking us for our finish stock. We're going to leave 5 thou on finish, 2 thou on the Z, and again that's just so that whenever the tool goes up on the Z to make that finish pass, it's not just running into that wall. There's not a lot of material there for it to take away. If you leave more, like 5 or more, you're going to really start kind of digging in with that tool whenever it gets back to do that finish pass on that wall. Again, these next two don't matter, but since they're red, that is indicating that it does have to have an input in there. So we're just going to do 0 and 0. First X depth, we have 3/4 inch stock. I'm going to start at 3/4 just in case it's off a little bit, or just to clean it up. 10 thou increment, depth of cut, which will be 20 thou diameter, clearance of 50 thou. Our start point, again, this is going to, just like your rapid position where you want your tool to come up to before you start cutting, and you want this to be a number that is greater than anything in your program. So I wouldn't want to make this 3/4, because then whenever it comes, wants to clear out past there with that 50 thou clearance, it's going to get confused and not do what you want it to do. And the pattern number, we're going to start with 1, and again that's basically just to establish your relationship between your roughing and your finishing. So now that we've got all that, we're going to store it, and we're going to start laying out the geometry of our part, and we'll do that with lines here. So we're going to go for a line. First one's going to be a rapid, so we'll toggle that. And again, I usually do safety moves here, just to most of the time, if you don't have your cutter comp on for doing radiuses and stuff like that, this isn't going to matter. But I just do it as a habit, just so whenever I do need it, I just do it automatically. We're going to store that. We're going to do a line, and we're going to be coming into this 472 diameter, which will be the inside of our chamfer there. So we're going to, again, this one will actually be a rapid as well. 472, store, and we're going to do a line. We're going to feed in to Z0 to the face of our part. Store. And we're going to do a line. We're going to be coming out to this, to the M13 here. So I'm going to pull out my little identification sheet, M13.75. See that our major diameter is about 511 to 505 and a half. So we're going to shoot right for the middle and call it 508. So we're going to go 508 here. And then we want a 20 thou chamfer, so we're going to go back minus 0.02 for that 20 thou. Store that line. We're going to come back past this undercut to where the diameter gets larger here, which I actually left off of this print accidentally. but I know that I'm coming back to 236. Minus 0.236. I'll look at my other print here. See that this diameter is going to be 525, so 525, store, do a line. We're going to come back to this wall, which is going to be 394. Come out to the major diameter of our part, 630, and another line. We're going to be coming back past this back edge so that we know that we clean up, which is going to, that's 590, so I'm just going to go ahead and go back to 650 just so I know that I'm well past it with the radius of my tool and all that. Store, do one more line, and again this will be my safety move, just to move away from the part before it tries to wrap it away or anything like that. Our part is going to be 630, so I'm just going to come out to 700 just to get it clear there. Store that. So that's our all our geometry and our roughing program. So now we're going to end it. We're going to store, and then we're going to do our finish. Now that was pattern number 1, so we'll input our pattern number 1 here. Do a feed rate of 3 thou. Spindle speed 300. Again, this second spindle speed in your finishing is always going to be your surface footage. It's not going to be your RPMs. So just be aware of that. And again, we'll just do the 1 inch and 0.1 just for consistency. Have it starting at the same point as our roughing program. So we're going to store that. Okay. Now that we got our finish, we're going to end it, store it, and we're going to move away from our part to a tool change position, which again I usually just do 10 inches and 10 inches. Store that. The next thing we're going to do is going to be coming and putting this little undercut in before we thread this section here. So we're going to call up our notch tool, which I have located in tool number 1. This one I'm going to keep a pretty light cut on, just because it doesn't like to dig in really, and again with that backside being so narrow, you don't want to push off your part or anything. I usually run this one at max it out about 800 RPMs and 200 surface foot. Spindle on clockwise, coolant on. We're going to store that. Now, this notch is 47 thousandths wide. I have a 47 thousandths wide notch tool. So basically all I need to do is move it into position on my Z and then move in X to my desired depth. So I'm going to go position. It's going to be a rapid. Our part again is 630, so I'm going to stay out at 750 just to give it some clearance there, and I'm going to be coming back. I'm touched off on the front of my tool, so the front of my tool is going to be coming up to this 236. So store that. Now, since I'm just coming straight in on my part, don't need to feed it or move it in my Z at all, this is actually going to be a drilling cycle. So I'm going to drill, and I'm just going to toggle down until I get to my diameter grooving. I'll re-enter that 2 thou feed rate, which would be 4 thou off of your diameter per revolution. Clearance is going to be your rapid depth for your X, and you can see that this is a little bit smaller than our 630, but I'm just going to come into that 630 just so I know that I'm still well away from my part, but I'm not wasting all that time feeding in. My final X step is going to be this 472 here. So I'm going to go to 472. First X step is basically where you want it to start pecking at whenever it's working its way in. So remember from earlier that this diameter was 525, so we're going to do our first X step at 520. X increment, we'll do 10 thou. Peck clearance, we'll do 10 thou, and peck increment is 10 thou. So this is how far it's going to be moving in. The clearance is how far it's going to move away as it pecks. And not entirely sure what the peck up increment is, but I always just do it the same as my clearance, and it does what it's supposed to do. I'll leave 2 thou for that finished stock, and that's basically, if you just peck in, it's just going to peck until it hits the number and back off. This will make it go in, stop on that last 2 thou, and hold there for 2 to 5 revolutions, a couple of revolutions, so that you know that you got a nice clean surface there. Our Z endpoint is going to be the same one that we traveled to before, which will be the 236 here for the front of our notch. Z increment, we're not going to have one. Don't need any relief, and no Z finish stock. We're going to store that. That's all we need for that one. So we're going to wrap it away again, position, back out to our tool change position, store. And now we are going to relieve this corner here so that it allows for a sharp pointed object to fit in there, because our tool right now has a 15 thou radius, and this will remove that. So that's going to be calling up another tool. I'm going to switch to a different turning tool that is at a little bit of a sharper angle, a smaller nose radius, so they can get in there and remove that without interfering with anything else. I'm going to do 5 thou per revolution, 1200 RPM, 300 surface foot, spindle on clockwise, coolant on, store. This is going to be another turning operation. We're going to turn, we're going to rough it. So I'm going to leave 5 thou on my X, and I'm actually not going to leave any on my Z. And the reason for that is, since I'm going to be cutting into this area here, if I leave 5 thou on my Z, it's actually going to cut deeper this way because it's going to be staying that extra 5 thou away. So this will just allow it to clean it up a little bit better. Again, don't need these, but since they're red, they'll need an input. Our first X step, remember this was 525, but we have that 15 thou radius, which is 30 thou on our diameter, so we're going to start at about 550. That'll be good. 10 thou increment, 50 thou clearance, and same as before, we'll do stay further from our part. Now this on the X, so the Z, we're actually going to go ahead and wrap it over to where we're going to be starting at. Instead of having it out here and then wrapping back and adding more lines and stuff, we'll just start at, we're going back to 394. I'm actually going to start at 384. So minus 0.384. This is pattern number 2. We're going to store that. Now we're going to lay out our geometry for what we want to do. We're going to do a line. It's going to be a rapid. It's 384. It's our safety move. Store. Do another line. We're going to be coming in, and again, this was 525. Our tool has an 8 thou radius, so we want to go in at least 16 thou smaller than what this diameter is, so that we know that we're eliminating the radius of the tool that we're using now for that undercut. So we're going to go to, we'll do 500, and that will give us plenty of clearance there. We're going to store that. We're going to do a line, and we're going to come back to that wall, that 394 wall. Store, line, and we're just going to come out far enough to get off of our part there, 635, and that'll clean up that wall and keep it in with that undercut there. So we're going to store that. It's all the geometry we need for it. So we're going to end. We're going to store. We're going to finish. That's pattern 2. With this being a smaller nose radius, I usually just do 2 thou instead of 3 thou that we did with the other tool. Surface footage is 300. Start 3/4 away and again at that 384. We're going to store that and end our finish pass. Okay, next we are going to be threading. So I'm going to go back to my tool change position again, store that, call up our threading tool, which I have located in tool number 8. This feed per revolution doesn't really matter because it's going to be based off of your RPMs and the pitch of your thread. I usually just put in 10 thou because it wants you to put in something there. Max RPMs, I usually thread at 800 RPM max with 300 surface foot. Spin along clockwise, coolant on. I'm going to store that.
How about that?
Now we're going to be doing our threading. So that was threading, multiple. We're going to be identifying this one by our crest diameter, and it is a straight thread. So we can keep both of those. Our start point, again, is just going to be your rapid area. So we'll just stick with that 3/4 and 0.1. Our crest diameter, 13 millimeters, is 512 thousandths. So we're going to do 0.512. Our end point, I touch off my threading tool on the front of the insert, but the tip of the thread is actually 60 thou behind that. So I want the tip of my tool to come past this point here, which is the beginning of my undercut. So I usually just go back to 250 because with the angle of it, you won't hit this corner here or anything. And I do a lot of these and they're all the same, but any of these tubes here come back to minus 0.25. If for some reason you need to do a left-handed thread, you could put in this minus 0.25 in your start point for your Z, and then have your end point be the 0.1, and still spin along clockwise, but you'll cut that thread backwards, and that'll give you your left-handed thread. Our lead, this is going to be a 0.75, M13 by 0.75. So 0.029575. I usually put in the whole thing and then just let it round off wherever it wants to round off. Starting angle is going to be 0. We already put in a chamfer whenever we turned it, so we don't need that. Don't have the chamfer angle. Our first cut amount, I always do 2 thou. Tool nose angle is 60. And then on our cutting method, I always do toggle this to the constant amount both edges. Minimum cut, I always do 2 thou as well. Finish passes, I do anywhere from 2 to 10 depending on the material and the diameter and how it seems to be cleaning up and the length of my thread and all that. I'm going to do 4 here, which tends to be enough on these parts whenever we make them. Store that. Okay, that's all we need for our thread. So I'm going to go back out and to my tool change position again, and I'm going to be calling up my little boring bar to do the rest of this work here. So we're going to call up our tool. Tool 3 is our boring bar. This is going to be a really small tool, not very rigid at all, so we're going to do really light feed on it, 3 thou. Surface, the RPMs and the surface footage will be fine the way we ran everything else. Spin along clockwise, coolant on, store. And this is also going to be turning and roughing. And you'll remember from the previous video that whenever you're roughing a bore, you want to leave a negative amount of finished stock on your X because you'll be closer to 0. So we're going to do minus 5 thou. We're going to do 1 thou on the Z, and again that's just so that we're not running into that back wall whenever we get there for our finish pass. These don't need anything. So first X step, I already have this 213 hole through the whole part, so I don't need to drill it before this, but we covered drilling in the previous video. So I'm going to do my first X step as 213, just to kind of clean that up and you know, make sure we're not just digging into our material there and snapping off that tiny boring bar. Our cut increment is going to be small, again just because it's such a small little boring bar going in there. Clearance, do 20 thou. Again, you don't want it to run into the back side of your part here. Whenever it tries to clear from this wall, you don't want it to come over here and hit that wall whenever it's trying to clear itself out. So keep that relatively small on most of these. Our X starting point. Smallest diameter we're going to be going to is 213. So we're going to do a starting point of, let's say, 180 on our X and 100 thou on our Z. This is going to be pattern number 3. We're going to store that. Now we're going to lay out our geometry again. Do a line. This one's going to be a rapid, safety move, store, line, another rapid, and we're going to come out to the end of our chamfer here, which is 433. Store. Do another line, feed into our Z0, another line, and we're going to be coming to the diameter of our actual bore and creating this taper. So we're going to move into 394 and negative 34 thou. So 0.394 minus 0.034. Store, line. This one's going to be going back to the back of our bore, which is 453. 3, store. And this one is going to be doing the angled wall of the back of our thread, which is going to be 213 and negative 507, so 0.213 minus 0.507, store. And now we're just going to do a little bit of a safety move just to get off of that wall there, so whenever it goes to wrap it out, it's clear of everything. Store that. It's all the geometry to lay out our bore, so we're going to end it. Store, finish, pattern 3. We'll do 2 thou per rev, 300 surface foot. Same start point, which was 180 thou on the X and 100 thou on the Z. Store that, end our finishing. That should be complete part. So we're going to go back, wrap it away well away from our part so we can get in there and unload everything. Store. And then I'm going to verify, make sure that everything looks the way that I want it to. Turning the outside there, drilling in the notch, undercut, threading, and boring. And as far as you can tell right offhand, looks pretty good. So I'm going to exit, exit, exit. Come back out here to my main screen. The boring bar that I'm changing to is a different corner radius than the one that I've previously been using. And since I have, if you were just doing all straight lines and stuff, you don't need to worry about that as much. But since I have these angles in here, having a different radius is going to change those points slightly to where my tool will be traveling to. So I always want to make sure that I change that description so the machine knows what is in there. So that's in parameters and then tool. And we're going to be editing. And again, that was tool 3 for our boring bar. The previous one was 15 thou radius. The one I'm using now is a 4 thou. So we'll input that. And anytime that you change any of your tools, just come to this page and make sure that it's got the right description for what you're doing. For instance, the boring bar is roughly in there like this, and you're cutting with this tip as it moves through the part. So you can see here it's got the geometry of the tool, and the little red dot indicates your cutting surface. And you can see this would be like a turning tool here with the cutting up here, and, you know, back cut several different things you can go to. So I'm just going to get back around to my boring bar. Exit, escape. Also in your parameters is your wear. If you need to change your cutter comp on anything, I'm going to go ahead and move my threading tool off a good bit, just because it sometimes varies a little bit on how it likes to cut those threads. So 10 thou is usually enough to know that I'm going to be cutting big and that I can move in from there. Everything else has been touched off and dialed in pretty well, so we're not going to worry about that right now, but this is where you would do that if you needed to. Exit, exit, done, and that should be it. Now I just want to load up my part, touch off all my relative tools, and should be good to go. All right.